We're going to get started here. Thank you for joining. We'll keep the door open to let everybody else flood in a couple minutes late. All right, so apparently some people didn't know what the topic of the session was that they were attending yesterday, so let's just be pretty clear on the onset. So we're talking about the SDN API, and then we're going to talk about the Lync SDN API, kind of what it is technically. Then we're going to talk about how a network monitoring system partner of ours, Nectar Corp, uses that API and how they leverage that for their monitoring solution. And then we'll have a moment to have a service provider partner tell us how they're going to use the information derived from the Nectar Corp network monitoring system and use that for their managed Lync services. So are we all in the right place? Cool. How many customers do we have here? 3? I only have 3 of these left. This is awesome. All right. So it's not that we hate partners, obviously. We love partners. But we're trying to reward customers for showing up. Where's the 3rd? Excellent. Thank you. Okay. So you guys all enjoying the show? Everything's good? Late Wednesday afternoon, probably a little dragging. Hopefully you got coffee. We'll get you moving here in a minute. Okay, so as I said, we do have the 3 sections to this presentation. I do have partners that are helping out here. I'm not domain expert in their environment. We've got Joseph Fucillo, who is co-founder, CTO of Nectar Corp, and he'll be giving some good demos for us. We have the esteemed Tom Tuttle, VP of Business Development and king of all things Lync SDN API. And then Jim Fry, our partner from Verizon Enterprise Solutions, who is the owner and developer of the managed Lync services that they're able to offer to customers. Okay, so what we're going to talk about today, we're going to, again, this is a 300-level course, so we'll go a little bit deep, not too terrible on the SDN API. And then we'll talk about, as I said, how a partner uses it. So I'm kind of repeating what I did at first. I just gave you an opportunity to get out, so now you're stuck. And then the service provider's view of automated diagnostics and how that helps them better manage their Lync deployments. So from the onset, with the SDN API, have any of you heard about the SDN API yet? Okay, have any of you attended sessions on the SDN API yet? Okay, so some of you guys are new to this. So let me think where we start. So the network industry has been transforming rather rapidly, and I think Gurdeep summed it up a bit. When VoIP came around, it made some changes, right? Voice over IP, and you could get IP PBXs. To the end user, there was really no functional difference. From a network standpoint, there were some differences, right? So you'd build queues, and you'd isolate VLANs, and you'd secure different traffic, which was usually your VoIP traffic on your network, and then you'd have standalone video rooms. But it didn't really transform much other than the service provider's cost model associated with providing backhaul of a lot of these services and efficiencies that they were able to derive by offering IP services. And a lot of it first went into their backbone. But again, from a user standpoint, nothing really changed, right? Well, what we have today is we have an environment where I can, me, Joe, user, I can sit at my desk, and I'm not just happy picking up a phone anymore because that's not really my behavior, that's not my motion. So what I'll do is I'll have some mobile device, and I'll have my own apps on it, and I'll want to talk to somebody. And then I'm going to want to have a video call, because maybe my wife is running around somewhere, or she's out at the beach, or I've got a friend traveling. And I want to do this where I'm working. And I want to do it while, on the clock. And I also expect it to work really well. And so that creates a lot of problems for historical network architectures. And so traditional management and network monitoring solutions depended on things like probes, right? And so you'd have probes, your visibility was only as good as some function of how many probes you had out there. You'd try to troubleshoot traffic and hopefully isolate problems. And there was a lot of guesswork associated with it. And it was always in a reactive type of support mode, right? Somebody would tell you, it's been horrible for weeks. And then you'd go try to look into it. Hopefully it would reproduce. And you could say, I found it. Yeah, we have a misconfiguration. So that's changing with UC, and the needs need to change. And so there's this concept of software-defined networking. I'll go into that a little bit more in this next slide, which is hopefully going to get us to a point where today, if you think about it, the network administrator defines and determines what service you as an employee or a user are able to use. And they also define what your user experience is going to be. Where we need to shift and where the world is pivoting is letting that user define what their communication experience is going to be. And we shouldn't care, right? As IT admins, as network admins, we shouldn't be concerned about that. We shouldn't focus on how do I create a QoS queue because, and how do I create a VLAN and how do I secure and authenticate traffic. We should focus on, hey, I want a conferencing policy that I can apply to certain users. And what this conferencing policy means is mapped from information from the application back to the underlying infrastructure. And then you get away from things like configuration drift from QoS, which always happens, because once you configure it, something changes, and if you don't have somebody who's over there to immediately start making changes to the infrastructure as well, ultimately you run into a problem and it becomes kind of a support challenge. So, are you guys familiar with, is anybody unfamiliar with the concept of software-defined networking? Awesome. Wow. Okay, good. Good. So hopefully you understand that we're pretty active in this space right now. Well, when we look at historically how networks worked, right, we had on the left is the historical part, just to be clear. Don't want to state the obvious, but I will. So you had routers, and you would configure things. You would configure network services based upon assumptions you had on how your users potentially would use that underlying network infrastructure. And if they tried to use a service that the network wasn't designed for or defined for, well, it was kind of their problem. What we would have to do when you'd have kind of this configuration drift, we would do, like, people like us, people like, other application and phone vendors would try to accommodate for the lack of a robust network by doing things like adaptive rate codecs, right? Because we couldn't specifically have the application define what we wanted to do, so we do Microsoft real-time audio codecs that can, use a certain amount of bandwidth when there's non-congested network, and it can adapt and go to lower bandwidth so that you can still have a call. Quality drops, but the users wanted a better experience, but you couldn't guarantee it because the underlying network couldn't support it. I mean, I'm trying to make a pretty strong point here, and hopefully it's becoming clear. But the legacy way of doing things just didn't scale. The first people to really figure this out were people who were managing data centers, the IT admins managing a data center, and then you go to virtualization. You start having VMs around or Hyper-Vs around, and you want to move them. And then, hey, we need to do a HADR experiment or exercise, and you'd want to move VMs to another data center. Well, I mean, that would take your IT team days, weeks, possibly, to plan to deploy all the new configurations within the data center environment. So quickly, the data center environments jumped onto this concept of software-defined networking. That's where you saw things like OpenFlow on this lower level start to be deployed. Now, what Microsoft has seen, and I'm going to make a bold prediction. You guys can argue it and everything. We won't do it now. You can yell at me later. But I do think that we're really the only predominant true UC application that's deployed in the enterprise space today. From one client doing everything. And so we've had to really address this problem head on. We've had to think about how do we create and enable network elasticity? How do we release this burden from the IT admins? How do we make this stuff work? So when we look at Lync and Skype and everything, if you've got that SDN model, the controller is the center of your universe. And that center of your universe is where the logic resides that's going to be able to define what services are available, when, how, what the priority is of it. And then that's sitting in what would be kind of your just center plane. Now, the concept of the applications above is we use this term northbound interfaces. So that northbound interface is that connection from your application down into the controller. So we developed this software-defined networking API, which is our ability to tell this controller, network management system controller, what we are about to do or what we have just started doing. So is this an audio call? Is this a video call? What are the requirements of it? Who is it going to? Where is it going to come from? Et cetera, et cetera, et cetera. So we give you all of that information dynamically. Then what the controller can do is it can look at the underlying resources. It can see the competing requirements for those resources and map a policy across the underlying internetwork infrastructure. So all of a sudden now, you've moved from a place where you're statically defining a network and hoping you can kind of adapt and do whatever and use whatever services you can, to where you've got an environment where you define a policy per user and you say this user can use voice, this user can use conferencing, this user can use video, whatever he wants to do, and at the time that they want to do it, they can tell the network, hey, this is what I'm up to. So we're talking about network diagnostics today. We're working on dynamic quality of service and adaptive traffic engineering, and ultimately we'll be into a model where it's orchestration and you're really defining things at a really high level policy. Got to get there. There's a lot of efforts, but we're working with standardization bodies to do that. Anybody have any questions on this? Kind of makes sense? Well, I mean, I hope it makes sense, but sorry about this. Okay, sorry about that. So the Lync SDN API. So what it is, and this is V1, we have now just recently released a V2. It happened after I put the deck together, so apologies. And I wanted to show you what we actually have today. So if you walk away and go, I've got a Lync deployment where I want to start leveraging this SDN API, you can do it instead of talking to Nectar and saying, well, yeah, we'll have something for you in a couple months. So the architecture has changed a little bit. It's become more scalable, quite honestly. But the concepts are the same. So what we have is, it's a RESTful API, so it's not real chatty. And the application is what we define as the Lync dialog listener. That Lync dialog listener is deployed onto the front-end servers. This Lync dialog listener then is going to wait to hear receive a message from a session being initiated. So what will happen in one sec, I'll get to that in one sec. But so what the API is addressing today is it's addressing audio, point-to-point audio, multi-point audio conferences. It's addressing video, and it's also addressing application sharing. We aren't notifying you on instant messaging types of communications, because if I instant message you and it gets there a second later, I don't think we've really lost much context. Okay, makes sense? So we're doing it for multimedia applications. Now, if you look at the diagram, so you've got the front-end server, you have the Lync dialog listener, and then the Lync dialog listener registers with the network monitoring system via a web API, so via a web service. Sorry, not API, via a web service. And so if you were to actually look through the configuration, you'd see a submit URI where you would place the URI of the network monitoring service. And then once we extract the data and send it out, which I'll tell you more about in just a minute, that's where it's going to point to. So the basic architecture and flow of the messages and how this API works. So a SIP message is going to happen. I'm going to call you. I pick up my mobile phone. Got the Lync app on, I'm on a wireless network potentially in my enterprise, and I place a call to you. Once that call happens, it could on the actual invite, or typically it's done on the after the 200 OK once you've got that SDP negotiated. We will see that message. The dialog listener will raise an event. It will invoke an event parser. It's going to an event handler, which is going to parse that message that it received. Going to extract out any of the relevant quality updates or relevant information like users, codecs, bandwidth, things of that nature. And then it's going to package it up into an XML document, and it's going to post it to that registered web service. And then they're going to start, they're going to log that. I'll show you a scenario where you'll kind of see all the different elements pulled together. Now, in this version today, then you're going to receive that update at the invite or 200 OK. If you change modalities, you start in an audio conference, and then you say, actually, hey, you guys want to do video. So you switch to video, you click on your video button, Then we're going to give you a starter update message, which is going to change your codec, which is going to keep the system updated to know actually how you're communicating. And then, once the meeting ends, or the conversation, the session ends, you can, we'll let you know that it's terminated, and we'll give you that information, which will include a quality update. Now, if there happens to be an error that terminates the session unexpectedly, then we're going to extract out information from the dialog header in the SIP messaging, and we're going to send you an error that there's actually been a failure. So we're dynamically telling you what's going on with these sessions, which is a completely different experience, depending upon how you leverage that information, of course. But we're giving you an ability to say, hey, something really went wrong. You might want to notify someone. So it's a very different concept moving forward. When we look at the XML output from the dialog listener to the network monitoring service, the output consists of Lync Diagnostics elements. One is connection info. Connection info is going to tell you who's speaking with whom, right? So you're going to get IP addresses, source and destination. You're going to get ports. One thing I didn't mention, I think I assumed this, so I apologize. Another problem with Lync, which is not a problem if you're a customer, but a problem if you're a legacy network monitoring service, is that Lync is encrypted, and it's encrypted by default. So typical systems today that are using probes are going to have to use heuristics. Heuristics are great. Heuristics is a guess. So we actually give you this discrete information. So trying to pick it up, we aren't passing out encryption keys. That doesn't make sense. If we want a secure solution, we wouldn't do that. So I just wanted to add that one piece of clarity that I forgot. I apologize about that. So the connection info, we're going to tell you who is communicating with whom and what does that information contain, like the raw SDP data. Hey, here's the negotiated codec. Here's the bandwidth available. Now the network monitoring service knows what's going on. And then at the end of a call or throughout the call, you have different child elements which are going to provide other data that's of relevance as well. So the invite information, which makes a lot of sense. Quality update, I'll show you an example of. And you need to know when things start and stop. So an example connection info. By the way, these guys chat quite a bit. And that's a qualified 3-pip phone specifically. So they're having a conversation. But what you see in the connection info, we've stripped out a lot of data in here. But the material stuff is, hey, this is a Microsoft real-time audio codec. So it's an audio call between the two. And you can see high-low bandwidth. Again, we had to do a lot of work to compensate for unreliable networks. So you can see that there's variable potential low and high bandwidth usage that's going to be associated with that codec. An example quality update. So this is after something's happened. Now today, this is at the end of the session. And I know that's not perfect. And we also know that in the QoE database, the information is averaged over the duration of the session, and so it's not perfect. And imperfection's okay, because it gives us room to grow. But what we're working on, and I don't have a release date for this, but we're working with our client team so that we can send an update once we pass a threshold at any time in the conversation, which would seem to make the most sense. Because what you see happening is if you have a user who says, I was on this conference call, I just couldn't really hear, it was really choppy, and then the IT admin's like, great, really appreciate the information. They go look in the QoE database, they see the average for the entire conference call, there were 50 people on it, 48 people had a great experience, 2 people had a horrible one, it's average, it looks awesome. How do you troubleshoot that? Where do you even begin? Same thing on a point-to-point call. You're on a call with somebody for an hour, right? 5 minutes of it, totally unbearable. But the rest of the 55 were great. You look at the network MOS score, it's pretty good. There wasn't a problem. You're crazy. That's you. That's your computer. That's something else. So there are gaps, and we understand that. We're going to help fill those. But we have partners that can help us in real time today by adding a lot of additional information to that. So if we look at this quality update, this was a great call, right? It was, and I'm not saying this was bad. This is just an example to be clear. But you have a 4.1A network MOS and your average of 4.2. That's a great call. Okay, so I'll go through one quick scenario just to kind of get you really thinking about how something like this can work. This is a service provider scenario, so I wrap in their network as their wide area network and assume that they're going to be able to expose some information from their elements. So if we walk through how the API works, we start the signaling, so hey, I have the intent to call you, so I press that I'm going to make a call to you. That initiates the signaling through the Lync server, goes back, notifies you, we start negotiating the SDP. Hey, 200 okay, we got media going, life is good, now we're actually getting on a call. At that point, now the dialogue listener is stripping out that information, it's packaging it into an XML document, and it sends it over to the the NMS platform. The NMS platform is now aware that there's a session going on. It correlates all of the underlying network infrastructure information. Now, this might kind of be specific to Nectar Corp. They've got some routing capabilities which are unique, but let's just assume that's the model. And so now they have awareness of the underlying internetwork infrastructure and elements of what's going on. And so then they can log what's the path for this call. Right, so now you've got all the information you need. You have two end users, you know the path it's going, you know the codec that it's got, the bandwidth required, everything else that you'd like to know about that. Mid-call, something happens. I don't know what happens. Could have failed, could have not failed. Could just be there's erratic something going on. So at the end of the call, we raise then another event where now we're sending up the QoE update over to the NMS platform. And in that quality update, it's noting that, that was a bad call, this was a poor NMOS score, something was going on, and you can actually action off of that. So, I mean, imagine this. Imagine that this happens. Imagine what's possible to make your life easier and end users happier. Imagine that happens. You alarm to your NOC. That NOC could be an IT admin NOC. The NOC could be something at a service provider for a managed service NOC. You're going to somehow potentially segment, your user group, and maybe it's an executive work group, and you see that there was a problem with a queue overrun on a private edge because they've been able to correlate all that data, and within some amount of time, I like to say 10 or 15 minutes, that's not really fair. Let's say like an hour or something. That executive admin gets a call from the IT group saying, hey, you know what? We know that you just had a bad experience, and we've already isolated the problem, and we're going to fix it. Now, I'm kind of living a little bit of a utopian environment with this, but if you've got the information and if you have the data, this is the power of software-defined networking, right? We're flipping the paradigm of what IT admin means, of what a user experience means, and of what a managed service means. So I'm going to hand it over, and we'll let Tom go ahead and pick up from here, and he'll start telling you about their solution.
Thanks, Mike. Hey, by the way, that was a better introduction than yesterday even, right?
Yeah, yesterday was a little rusty.
I'm thinking by the end of the week I might be a supreme being or something. So we really appreciate the opportunity. And what Mike relayed is, it goes back to specifically what Gurdeep said in his keynote yesterday. It was about trying to drive towards that consistent experience for the end user. Coincidentally, our tagline happens to be, every conversation matters. In order to do that, you have to have a complete picture of what's going on. And with the SDN API, it has really expanded our visibility in the entire Lync ecosystem. So what I want to do is I'm going to do a setup. We're going to spend most of our time kind of showing you the actual demo and how we actually consume that API and what we do with it. So I'm going to start by just kind of showing you a little bit about how we got to where we are and how big a picture we have of that ecosystem. So we have the basic information. You have a performance monitoring of that Lync infrastructure, including the QE database, right? So we take and incorporate that information along with what we know about coexistent environments. We have deep knowledge and insight into Avaya and Cisco environments because oftentimes they're in play somewhere as they're making that migration to Lync and whatever else. So if you can take that information in, you're going to avoid a lot of the bumps along the way through the transition. We also have deep understanding of the routed topology. And this comes into play directly with what we do with the API, which I'll get into here. But understanding Cisco and Juniper environments, as well as we're going to introduce a Wi-Fi module here in the next 60 days, which will be beneficial to correlate in as Lync traffic hits that endpoint or that premise. You'll know exactly how that customer is moving around from different access points to see if you have a problem in that environment. And then we also have and incorporate the information in and around SBCs and gateways. So we take all that information, so we have a pretty good baseline understanding of what's happening within Lync. But then what we do with the API that sits on that Lync front end, which Mike described, we take that information and then we are able to take the information and correlate calls as they traverse the routed network, the client routed network. And that's critical because now instead of having Lync traffic it's encrypted and you have no knowledge of really trying to pinpoint where problems are happening, now you have the ability to drive down to that. So this is exactly how we leverage the API. So historically when we've played in other legacy UC environments, what we do is we will analyze RTP traffic to derive our content metrics. Then what we do is we'll look and we'd analyze SIP and H323 as well as other protocols to derive the session metrics. So that information is interesting, but the key part of what we do is we natively speak OSPF and BGP. We're like a router that does not route. But once we peer with a single router in a domain, we know all the route tables. So as calls go across interfaces, we know which interfaces are having a problem, and so on. That's unique information that now you can really drill down into where the problem is. Things that would take days, weeks to try to triage problems in Lync, now you have the ability to do it in a couple mouse clicks. That's that complete view that we call of the end user experience. And because that information is coming from that API, you don't have to put that, as Mike talked about, that large distributed deployment of probes throughout the network. You can put one or two in strategic points to be able to bracket around things, but now you just have a much leaner way in which you can get this information. So Joe's going to come do a demo, but let me set up the environment that we're looking at here. So think of this as a typical client environment. Down there in the bottom left-hand corner is like a data center. So you got routers that are carrying traffic and traversing in and out of that environment to 3 locations, London, San Francisco, and New York. Behind that, you've got Lync clients. You also have some coexistent Avaya. In this case, in this demo environment, you got some Avaya and Cisco UC deployments out beyond at the premise. Those 2 green boxes that you see there, those are where we have strategically put our analyzer or our probe. Because the API gives us that information, not only does it allow us to correlate calls across the network, but it also allows us to do real-time media analysis start to finish. So we know at what point during that call that the service may have been degraded, okay? So we can look, again, at real time. So we know as things are happening, we're able to look at that call to begin to analyze it. So you would put that near a voice gateway or near as traffic was departing where the media is being collected as it departs, let's say, a data center. So we're peering with the routed network, so we understand QoS settings via some polling that we're doing as well. And then the API, which Mike described, sits on the front end and then delivers that information into our platform. And that's how we kind of pull all this together. So then you have that complete view of end-to-end. So with that, that's kind of the setup, and then we're going to dive right into the demo. Any questions on that before we do? Okay. All right, Joe.
Hello. How's everyone doing? Good. Good? All right. So I couldn't see before. So show of hands, who end customers here? Great. And then partners, integrators, resellers? Okay, cool. So some of the end users here, curious in your Lync environment, so they pure Lync end-to-end, any legacy systems, any integration between legacy and Lync or pure Lync?
We have pure Lync, but in some of our remote offices in other countries, they have Cisco.
Okay. Mixed environment? Can they dial from, those who have mixed environments, can you call from one environment to the other? Yes. Is that painful sometimes? Trouble?
Unfortunately, I don't have to deal with it. It didn't work through Cisco call.
Oh, I'm trying to use the mouse. I don't know, it's not working. Not for that laptop. So I just didn't apologize in advance. Unfortunately, I have a flight that I've just scheduling was. I'm going to leave kind of after I do my piece, so it's nothing negative, nothing, not offended or anything. I need to get to the airport. So with that, we're going to start with a couple of screens. We're going to take a high-level view of our application. So for those who are service providers, so I'm going to start a little high, and then we'll move our way down, and we'll really get into the weeds, into some of the things we talked about here. So for our application, if you're a large multinational and you have lots of sites, the location list on the left side would be sites in your network. If you're a service provider, you're looking at here is our client view, where the left column here, the location column, is where you would have different customers. Inside the client environment, in your environment, on your network, are servers that collect software. The system is a tiered model. It can be complete standalone. It does not have to be tethered up, but it can be tethered to a remote service provider NOC, where alarms and information that we're collecting can be brought to experts who can then react and help for co-management, managed services, maintenance services. So it is a tiered system. What's unique about it is that it's designed to be completely isolated or hybrid or a mixed mode. And it was designed to do that. So we're going to look at just some high-level views of systems, and then we're going to kind of drill down kind of into some of the items we discussed. So what you're looking at here is a dashboard of a customer out in Europe, and you can see here it's a high-level view. We're looking at their overall WAN location health on their network and the connections to the links of those various sites. And then this customer wanted to have some trunk group health on the right side. You can see there's tabs up here where we could navigate to different views and to phone quality and reports, location, different information that can be aggregated together. And we have modules, software discovery, we have modules specifically made we obviously have a fantastic Lync module, we believe, and we have some very unique capabilities there. But we also have other environments. So those who have hybrid environments, what we like to do is help you smooth that transition between. So I'm going to bring some dashboards up that'll show you, say, a Lync system connected to an Avaya telephony platform, where you, the Lync administrator, can actually see the health of the trunks that you might be getting voice calls on, so that you have a little more insight into what's going on. And it's not just this. We could say, you could say, hey, I could see I have a problem, and you can understand your impact. So we have a lot of dependent relationships we can map. And so I think one of the key things is that we're all going in a certain direction. We're at a Lync conference. We know where we're going, right? The market's going a certain way. The customers are going a certain way. But there's big environments. And to get there, and the smoother we can make that transition to the users, the less pain we have, the faster adoption we have. Because when you have problems, things stop, finger pointing starts, slows down rollouts. And it is just super complex. I mean, there's no two ways around this, is that these environments are ultra complex. Another example is we could show you down to a site level. So here's something, this is on one of those locations that I was just on. I could drill into that site and actually have a site view. So here I could actually see telephony devices connected to the network switches, and then their connection to the internet and the bandwidth. Again, helping you kind of, from your desk, be able to view into that user environment. As we kind of get a little tighter into this, we can then drill in and say, let's look at here a Lync environment. And this is a standard edition environment, and the concepts are the same for enterprise edition in terms of, and we put this together just to give you some examples. So on this dashboard for Lync is both some server health, some performance, the overall status of how, you can see there's an alarm on Lync, and it's actually a front-end problem, and we can see the back-end mediation is okay. We got some CPU memory, just some basic server health here. We also added on here, that I was mentioning earlier, some trunk health. These particular trunks, now this could be audio codes gateways, could be session border controllers, Sonos, and we do have modules for the full ecosystem, which makes up, and then in this case here, because it's connected to an Avaya legacy environment, and Lync is getting its external dial tone from this Avaya system, you, the Lync administrator, can see the health of all those trunks that calls might come to you on. So that way, a Lync user has a problem, they can't make a call, and it's outside. You can, You don't have to make phone calls. You can look and say, hey, trunk group 12 is out, or something's wrong on the dial tone. Maybe you could change some routing on your side to get around that problem. So one of our big things is, and you can see here we have, I'm not going to go into these, we have different tabs for different vendors. So you can get into the hybrid environment. Now, if we look at just a concept, and we're going to get a little deeper. So why is Lync red? We would double click on this. And conceptually, I'm going to change this. So this will be called dependency tree. So this is something we build out of the box standard. We build a lot of trees and it's a relationship mapping between components. And this is a fairly simple relationship. It's a Lync standard edition, but it's showing you, hey, I have the server roles. What's the health of those various roles? And if you imagine this was an enterprise environment where those roles are spread across big farms and you have multiples of those, it's very visual to drive what's my status, what the problem is, and if there's an issue, you can see it's red coming up from this particular node here. There's something wrong with the front-end server. If I click on that, I get the event. I can go into the actual alarm and event that's causing a problem on the front-end service. These types of things get emailed out to you. They go on your dashboards. And we could build really interesting dependent relationships between, say, an Avaya connection and a trunk or a Sonos session, and gateways say, hey, it's this mediation part, this part, these are connected to each other. And that way, when the alarm comes in, we're not just passing events to you. A lot of network management tools just pass events. They run them together, and they don't give you enhanced, what's the impact of this? You know, and so forth.
Where's the status coming from? Is that being fed to you from the Lync, or is that something you're pulling from the servers? Or?
So in that case, there we were monitoring. We directly go polling the server, but we're pulling stats over either SNMP or WMI. We're going server cell. You know, basic stuff that you have other tools, but it's in one place. The point of it is that it's giving you now. And as we drill further in, we can start talking about call quality. So here I'm looking at call quality. So now I'm looking at the QoE database, and Microsoft has provided built-in some quality monitoring metrics. And this is so here we're running a SQL query, and we're pulling those quality metrics up. And over here is some charts for the day. There's 43,800 calls, a lot of red in here on purpose. This is that demo lab that Tom was telling you about. We have a wide area network, and we purposely create problems on the links so that we could show you, what does it look like when there's congestion, or we drop an interface, and we cause real-world problems, and it's continuously breaking things, and it causes this environment to. So this is as close as we can get to actually breaking a production network, because it is production, it's live, there's real Cisco routers on it, and so forth. And we just do really cruel things to it. And so, kind of, you guys familiar with the QoE database? Great information. And we have things here. We could see, source and dialed number. So just to give you an example of, we're going to go a little further with what Tom was talking about, the Lync. This is not the SDN API at this point. This is standard reporting, what you get from the QoE database. So we pull it in. We look at the MOS score. So we could see here is that 1143 made a call, and he called extent 1026, and it's 4.19 on the source side, the person who made the call, and the destination MOS score was a 2. Okay, and if I double-click on the record, I can get the device they're on, what kind of headset, the standard, the things you expect that are in the database. Now, this is frankly where products in the market stop. They could take all this wonderful information, give you reporting on it, but where and why? Why did this happen? Where is he logged in? What's he going on? What caused this problem? How widespread is it? How many other sessions were affected? But there's a lot of red here. Were they related? Were on the same call? You start asking all these questions, and you want to know more. And this is where we've been able to do a lot of enhancements. So what I'm now going to show you is this is where, again, QoE is stopping, and I'm going to go in and use the SDN API interface. And what I'm doing is I'm bringing up that same call, fingers crossed, we've had some challenges today, in this application. And if it doesn't, we'll just go grab it manually, if it doesn't pull straight into it. So we could see here that the London sites had a bunch of poor calls. And let's go bring them up. So this is a slightly different view of that call. So now we're looking at how did that call get over the network from one source to the other. That's not the right call. Yeah. Which one of these, Tom? That's much better. Okay, apologize. Okay. Okay, so first here we could see we experienced congestion, was why we had a bad call. Okay, how did this happen? So when the call took place, the SDN API gave us the IP address of the devices of who we're communicating. We then looked in our internal route table, because we don't have to advertise anything, we don't talk to the network, we don't, we just listen. And we build in memory a route table that's how we get around your network. It's like a map. So if you give me 2 addresses, I can tell you at any point in time how you would get from point A to point B through the network. We keep that in real time, and we understand exactly also which interfaces we're going through in one Ethernet, out a certain serial, in one interface, out another interface. Not just the actual hop, but which interface it went through, because that matters. Because a lot of it's not every interface. There could be problems on a certain interface, and you want to know exactly. So you can see here we're going ETH31, and there's a priority queue issue here. So we create this route map, and then what you're also seeing here is the circles with the letters in them are points at which we're measuring quality. 2 of those measurements came from the Lync client, and that's that end of call number. So today, I think Pascal had announced in a session yesterday, so today the Lync SDN only gives us the number, the same metric you get from the QoE. It's the end of call number. That will change. So sometime next year, whenever Microsoft will be providing mid-call updates through the API, which will be providing a much improved, not so much averages now, we'll be getting real-time information. But today we were able to overcome that. So as Mike mentioned, because the SDN API is telling us who's calling, what IP address, what port they're on, we have a probe on the wire, just a packet sniffer. It's just a mirror. It's just basically and the best place to put them is by your front-end servers. Simple place to put them. Another great place if you have session border controllers and where you're aggregating a lot of traffic, it allows us to kind of really get inside there and see what's going on and inspect that traffic. So basically where you see A and E up there, and then on the other side B and D, it's the same probe. There's 2 probes on each side. And we're measuring quality as it comes in and out of the network, okay, right before it got to the server. And in this case, on the large edge as well. And because we have the kind of keys from the SDN API, we understand exactly which conversations belong. Now we can get latency, packet loss, and jitter, and create a real-time MOS score throughout the entire call, not just an end of call average. And what you see down here is a reflection of the different points of measurements, A, B, C, D, E, F, and quality there. And we can see here that B and C are the real problem child. So we look up at B, and it's right here. It came out from this side, went across the network. We had a problem here. We experienced congestion. If I want to know more about that, I can go click on NetFlow, and I can look at the actual other traffic that was going on. I can look at the priority queue. So we are speaking SNMP, and we're just pulling those stats out of those Cisco, Juniper, whatever routers you have, pulling that info in and bringing it in one place. So in this record here, you've got the network information, the link information, your topology, quality all tied together, telling you exactly where and why. And then Tom will talk some more about related sessions and other things we could do, some unique value. And I also could see here that at point B is where it began to have, as it came out of the network here, was the first place our software probe picked up the problem. And then the Lync client on the end also reported it. And that's reflected here on those 2 spots. Now the difference between, there's a chart here. That chart brings up the MOS score throughout the entire session of that call, not just the number. Whereas this here is the average that came from the Lync client. And we've had a problem with this demo system today, so I'm not sure if they fixed it or not, but there was a database issue because it couldn't pick a worse day to do it on.
Yeah. Yeah.
But worked great yesterday.
It did. So,
and it would show you a nice little MOS score chart right here of the MOS score throughout the call, not just an average. And what we've been seeing a lot of, because the way it works is, is the MOS score might depending on where the impairment came in or in, it could be poor the whole call, or it might have been poor and then it cleared. And you'll see, and we've seen a lot of those where you say, hey, look, it went back to a 4, but the average said it was a 2. You know, and so that moves around.
So yeah, so a couple things like what Joe was saying about the related sessions. So again, for like conference calling, if you had however many participants on a call, and oftentimes to go dissect if there was a problem, find that 1 or 2 users out of the 50 that might have been on that call, you got an average. And so to try to go dissect that stuff, the API allows us then to do a related session search on that conference ID and look at all the participants with their individual MOS score. So then you can really zero in real time where the problem is with that particular user. The other piece of this is that when you look at, not only do you get event notifications, so if there is a path down, if there's congestion, you'll get notified immediately because we're monitoring those routers as well, so we understand those. We get those in real time. At the same point in time, it has the DVR capability, so if you have a user that calls in and says, you know, I had 3 bad calls in the last couple weeks, could you take a look at them? That is extremely manually intensive. All you got to do is go in and put in their user ID. The API has already helped us identify each of those sessions, so you can go back and dissect those and still troubleshoot those for those individuals. So the API, I mean, without that, it's you can only go so far, and you kind of are left it to do a lot of manual intervention. Let's put it that way.
So how do you capture all that intermediate, traffic between the routers? They're not my routers.
So like service provider cloud? Right. So
Hosted data centers or whatever case.
Right. So we like to look at that as the cloud, right? And so visibility into the cloud, and Mike is going to talk a bunch about that, about Jim, sorry.
He's Mike.
Someone over there is going to talk. And a purple shirt. So Jim's going to talk about how Verizon into that cloud, right? But so from those of you who have MPLS networks, parts of the network that aren't yours, the best you can do there, as we like to say, is watch it as a leisure network. And you could say, hey, it left good, and it came out the other side, it wasn't good, right? You get something in the middle. So you can go to your provider and prove to them that I can show you that when it arrived from out of that cloud with the following problems in it, and you could we call bracketing around the unknown. So that's not your domain. But the best you could do there, and so you can isolate it, and at least and a lot of this is about that called the left and the right. Is this a data network problem, or is this a Lync issue? Is this my own network, or is it my provider's network? Because when you can make those hard left and rights, you take huge amounts of time out of isolating problems, getting down to it. But, and depending on your provider, they may or may not let you have some visibility into there. We're trying to work with some of the service providers about that.
I think it's Verizon.
Any other good? That's a great question, by the way. Any other good questions? Come on. Questions? Yes.
What about on the other direction, where if I'm a hoster and we want to look into the entire end-to-end call, which isn't in our network, it's in the customer's network, how are we going to help?
See, that's the one. As a provider, we do a lot of those. Okay, so because you're getting a phone call, right? You're the provider, it's your problem, whether it's your problem, unless you can prove it's not your problem. And it's not about deflecting, it's about helping, right? So this is multi-tenanted. This is designed to be in the client's network. So you could look at the service delivery model, and you could look at it 2 ways. You could look at the demarcation point and say, this is the edge of my cloud. And what you do is that's where you definitely have a probe at the edge of that cloud. So you could nicely show your customer how when it left my domain, my cloud, it was really good. Look. And then what we're encouraging our partners to do is to make that part of the sale, is that we want you to put pieces in. And the customers generally want to know quality too. They're going to say, okay, so I could provide a service to you, and I could put a couple of pieces of software in your network, and I could bring this all together, and I can give you dashboards, so you customer can see your call quality, and we can bolt, and you remove that kind of the visibility, and provide visibility into their network as well as yours, and it's transparency. So, and that a lot of our customers are doing that, and a lot of our partners sell that into their client, so that you put, and then essentially, if we go back to that where we first started earlier, is this, you're coming from a global view. These are all your clients on the left side, and you can see quality, and you can go down and drill in, and you have means of measuring them and helping them. Good. Okay. Well, thank you for your time. I'm going to leave everything open here. And we're going to go back to the deck.
It disappears. All right, so I don't have a ton to go through. Obviously, you can see a lot of things that they add to the solution. What I'm going to talk about is really what Verizon's looking at and why we as a service provider for our customers and the way that we look at that whole solution across the board, why we are concerned about this stuff, why customers should be concerned about it, and what you can look at and do. Standard topology, nothing special about it in anything except for the fact that where Verizon's layer on the management system there is where we look at taking the Nectar solution, putting that in to that and tying it across the other pieces that we have already, right? As a network provider, we've built solution and system for years and spent tons of money on doing that, from network management tool sets and capabilities. But when Microsoft comes out with Lync, it's not standard based, right? We have different solutions that we need to look at and how we consider it and what we look at. So we've been partnering with Nectar to put that into our solution. Verizon has a system, and I know there's one guy that said customer says he's probably got Microsoft or Verizon's network. What we call that is impact. There's a bunch of different tool sets, and then we'll drill down to kind of where those are and what that looks like and tiers that go across that. But what it does is it covers kind of the 4 boxes that are there, right? We've got fault correlation and detection across that, and the restoration. It's built into parts of that, right? Detection, automatic restoration type pieces that are built into those, as well as protective outages, fault isolations, putting things off to the side, repair actions that drive tickets and management to the NOC and the service, the guys that are running those services across that, right? As well as then putting all those best practices that we continue to learn all the time back into that system and solution and continue to evolve that as it goes along, right? And the advanced features that go through it. So the impact solution then, these are the tiers that go across that before the Microsoft piece, which is down at the bottom, where we have basically what we call the tier 1 is the alarm and event correlations, right? We're taking a look at the WAN and the LAN analysis. Smarts is part of that, which is the managed service portions, as well as EMC Ionics, where we take those solutions, plug that into that impact tool so that it correlates across there. We can trace tickets all the way across from end to end in those solutions. We look at then tier 2, which is the analysis and control part of that, right, where we're starting to fault handle those things, or handle the faults and diagnostics, tracking, and the closures of those, whether that's automated or looking at correlations, workflow management across that, all the way into the tier 3, which is then the repair, right? The Verizon NOC gets involved. Those things are happening after the automation, data center ops, service desk, right, in there. So what we did then with our Microsoft solution was actually went a step farther than just having SCOM involved with the agents and the gateway and everything, taking a look at that application. We actually integrated that with our impact tool set, right, and smarts and Ionics, so that when something happens in that environment, it's automatically fed into there so that it is part now of the end-to-end solution across that. As we add the Nectar portions to this, now we get a better view into not just the application itself. Was it up? Was it services running? What kind of things are going on from that side? But now we actually get to see performance in real time on voice, which we haven't been able to do in the past, right? And in looking at each of those. So we have those now into that SCOM portion to be able to monitor that and take a look at it. We then, of course, feed a lot of network information, the information that we have and use from our end, as well as the customer's network, into that and be able to look at all of those different hops, because without that, their tool is going to be limited as far as what they're able to cover, right? Without us giving that information to them. They can say, hey, something happened in between here But if we're not letting them talk to the network itself, we're not going to know what hop that happened at, right? And what kind of things were really happening through that solution in doing that. And that's what we've done and continue to work on and move toward and to do for our customers. So any questions on that? On where we are, what kind of things we've done, what help it's been? Does it make sense? Does it look like something you guys go, oh, right? Right? Because it is, when you look at that from our perspective, you're really looking at an end-to-end solution, right? You can handle and have somebody manage part of it, part of the network, and you can have somebody manage your voice pieces over here, and you can have them manage the applications, but unless you bring that stuff together and give it, from end, I mean, this is really a true end-to-end solution, being able to provide appropriate SLAs and uptimes on that based on it, because otherwise you can't deliver it. It just doesn't happen. So there we are.
Cool. Jim, thank you.
My pleasure.
Awesome. Tom? All right. So was this reasonably helpful? Generate some ideas? Make you really comfortable about your Lync deployment? Hopefully it will. Oh, we missed one slide, Jim, but I think we're running out of time. Okay. All right. So any general questions? I mean, we've received some questions. Any general, specific, stupid, horrible questions? We love those. Really deeply insightful questions. All right, couple things.
I'll ask them. So, how much is this used? I mean, we've heard from Verizon, either other vendors using it, or is this something that we're going to be hearing more and more from? Let's support this on our equipment.
That's our goal. Yeah. I mean, I think there's two avenues to moving in that direction. One is we are early. So when we look at this, we have a standardization effort that we're driving. And actually, a guy, Pascal Meneses, on our team is driving standardization of a UC&C northbound interface within the Open Networking Foundation working group that's doing all this SDN activity along with the UCI forum. In order to achieve, so we want to standardize the northbound interface regardless of which vendor you have, right? I mean, that provides protections against, multi-vendor environments, and it should provide some sanity for customers at the end of the day that you've got a common means of managing your network. So we got to move towards standardization. I'll get to your point. I just want to provide some background. And then we need to have something in place that's actually working, because you don't standardize ideas. You standardize actually working code that's in place and that's adopted by customers. So we're actively rolling this out and getting it deployed, more so I think in customer environments today. And we're going to see Verizon then picking it up and starting to use it a bit more in their solutions, which is great. We'll see potentially other service providers start rolling. But really, when you look at a lot of these big providers, I mean, Verizon's been super helpful to work with on this, because they've been kind of a little bit more leading edge and willing to adopt something that isn't yet, doesn't yet have the global stamp of approval, because they see the value and benefits derived from it. So I think that we'll see that activity picking up, but we are working with other service providers having these conversations as well. So
Is that logged somewhere in terms of who you're working with and how they're the main thing I'm concerned about is vendors, service providers, whatever, using this technology, but branding it in a way that I wouldn't even recognize.
yeah, I'm not sure how we protect against that ultimately. I think what I would ask of customers today is ask your service providers about it. So if you've got Verizon, well, follow up with Jim. And if you guys have other carriers, ask them about it. See what they're doing. I mean, we need to transform an industry in the way that it does business. And cultural inertia is very real. And it's very hard to change things that are in place. And there's Cisco's done a great job, because they've been the dominant networking vendor, of creating a union that's a workforce globally that can configure their stuff. This represents a threat to a lot of that stuff that they typically do. So we need to get over that through customers recognizing the value, partners recognizing the value, and driving us to this place where we've got elastic networks that are self-healing, that can define and define and configure themselves based upon what the user wants to do. And so I think there's an ability today, as we're showing you, to actually do something better with your network. To get to where we want to be, that utopian vision of orchestration and adaptive traffic engineering, where you're dynamically routing around faults and failures and changing QoS queues that happen, I think we have a little work to get there in a real widespread manner.
Yeah, I guess my concern is just as we talk about overcoming inertia.
Yeah.
I'm not the network guy.
Yeah, yeah.
And I have like a say in that. If I can say, this is a new technology that would help Lync, by the way, this is a really easy way to, kind of understand it and use that as they turn and look at providers or equipment or something like that.
Yeah.
That would be a bonus. But if I say this is something that would help Lync and they don't understand it and they're busy doing other things, we might get it, we might not.
Well, and so that's, right now there's two deployment options, right? You can do something yourself and bracket your service provider network, or you can go all in for a managed service, and maybe that's a determining factor in the managed service provider you evaluate.
But we
If
can
it's our
also,
world,
But it
we'd
would
like
only
that.
be one of many, right?
Yeah.
That would get lost in other things such as cost and other much bigger WAN issues and throughput only.
Yep.
It really doesn't directly affect this technology.
Right. And we have an open interop program that's going to be qualifying different, NMS platforms and things of that nature. So you'll have more options and more choice as time progresses. Yeah.
and your service provider, like ourselves and Nectar, should be able to come in and support and talk to the data people appropriately in that kind of language, to show them the benefits and to show the different things that can happen in there with whoever you're going with, whether it's myself or somebody else. Ought to have that knowledge and capability to do that, to sell them on those. Because once they start to see it from the language, from the data side, and what that means and how that translations and what it does to their network to help them, most of them should at this point understand SDN pieces, if they're at least smart enough to stay up to speed on where the networking pieces are going. But we should be able to handle that stuff and help to make that voice solution better, especially because those data guys are getting involved. They want to have that solution out there that actually makes sense, and they don't want to be the ones blamed because something's not working appropriately, right?
Okay, so I opened up this session saying, hey, we hear sometimes people aren't really aware of the content of the session they're joining. So hopefully we clarified that. You guys were in the right place. And lastly, I've also heard that we are Big Brother here, quite honestly. So we look for evaluations to give feedback on ourselves, on the content that we provide. Hopefully we won't get fired from the feedback, but we do like it to be honest. We probably won't get promoted either. But do be honest, because it helps make this event better for you guys and all of our events better for you guys. So if you would, just take a moment, fill out the evaluation when you get some time. Let us know how you think we did. And then we're always open for feedback from customers and partners. So if you think there's a better way to build this mousetrap, or if we're missing things, great feedback, good time to give it. And also track things that are going on with the SDN standardization if you're interested. We're working hard on that. We're hoping within the next year we've got we're close to that point.
I noticed there's a lot of other sessions going on. Can you elaborate on, what are they going to cover?
Yeah. So we might have actually missed most of them. I think there's an SDN Wi-Fi session right after this one, right across the way. It's right in here. Oops, right after this one right here. Thank you, Sasha. And I think you missed the higher level general overview of what our strategy is moving forward. But all of these sessions are recorded, so you'll be able to go back into your MyLink portal. You'll be able to see which sessions there were. You'll be able to download decks. You'll be able to view recordings, so you can definitely catch up. Cool. Thank you guys so much for being here. We obviously wouldn't be here if you weren't, and so we appreciate it. And enjoy yourselves this evening. Mm-hmm.